Okay, everyone, there's still a few people coming in. Okay, so welcome everyone to the Test 2 Masterclass or Learning Units 3 and 4's Masterclass for FINM7321, so Financial Management 3A. This is the Masterclass for your test that's happening next week. Your Test 2 is only covering Learning Units 3 and 4. This is a change from last year where it was 3, 4, and 5. So it's now only 3 and 4. Okay, so just so that you know who I am, my name is Claudia Darosha. I am a lecturer at one of the Varsity College or Varsity brands. So I do lecture the subject, and I did do the master class as well, the last one. So I'm doing this one as well. So welcome to the session, everybody. All right, so overview. So what are we going to cover today? So as I said, we are covering learning units 3 and 4. When we're looking at each learning unit, there are specific items that need to be known. Formulas, more formulas again, like we had in our first masterclass, but not as many that need to be known this time. A lot of them do, well, at least one of them do carry on from formulas that you have learned before, especially from learning unit 2, which I'll unpack. But again, there are formulas to learn, not so many, but still more that you need to know. So in terms of learning unit 3, there really are 4 main topics or main, I would say, calculation-based topics that you need to know. So the first one is expected returns. You need to understand, or you need to be able to calculate and interpret returns for both single assets and portfolio of assets. Single asset meaning only a project or a share or a company. Portfolio of assets meaning more than one share, more than one project, more than one company. We then have standard deviation, which is a measurement of risk for both single asset and portfolio of assets. You need to be able to do it for both. We have coefficient of variation, which is also a measure of risk. So single asset and portfolio of assets for both. And then you need to know capital asset pricing model or your CAPM. Okay, so that's just for learning unit 3. And again, or just to summarize, that whole learning unit is all about risk and return. So everything that we are covering or everything that's covered in that learning unit has to do with return and risk. Then we have learning unit 4. So learning unit 4 is mainly around bonds. That is the main topic of the learning unit. So there is also theory in this learning unit, which I'm not going to cover today. I'm just covering more the formulas and the calculations. But there is quite a bit of theory, especially on the learning curve. So you need to know your different curves for bonds, and you need to be able to interpret them and explain them. There's different theories as well. So please make sure that you do know that. Again, I'm not going to cover those today. I'm just going to cover more the calculations, the formulas, and the principles around that. So 2 main calculations in this learning unit 4, is your nominal interest rate and your bond valuation. A nominal interest rate being how do you calculate a rate that's inclusive of inflation, and then bond valuation, how do we value bonds if we want to invest in them. So it's from an investor's perspective. All right, so formulas. So I have again listed all the formulas applicable to learning units 3 and 4, and then I will unpack them on a whiteboard and mural just so that we can understand them a bit better. So I will do that. So the first formula that we have is your expected return specifically for a single asset. So this is what these formulas are for. There's 2. The one on the left is your return on investment, and the one on the right is your return when there's a probability Okay, so either one of these can be asked. The one that is mostly used is the one with probabilities, where they actually give you a range of different outcomes and the likelihood of that being achieved. Okay, so the one on the left, we have RT is equal to PT minus PO plus CT over PO. I will unpack that a bit more. I have indicated underneath here, what does each item stand for, but I'll unpack that on the mural, and as well as our RE is equal to RJ times PJ, which is in essence with the probabilities. Okay, so this is for expected return of a single asset. Your probability formula can also be used for multiple assets, but normally it is for a single asset. Okay, we then have expected return for portfolio of assets. So this is when you have more than one share or more than one investment or more than one company that you want to understand what the return is. So the formula being your return is equal to the sum of the weighting times your return over N. So if you are looking in your textbook, you will note that this formula doesn't have the divide by N in it, but it must. Okay, so please just make a note for yourself in the textbook, as well as when you are calculating, you must divide by N, which is the number of periods. So you must do that. So please make sure that you are doing that. But again, I'll unpack this a bit more detail on the whiteboard that I have for today. Then we have standard deviation for a single asset and portfolio. So there are two formulas used either for a single asset or for portfolio of assets. Generally, the second formula on the right with the N minus 1 underneath is used for portfolio of assets. That's normally when it is used, and the one on the left is for single assets, but they can be used interchangeably depending on the information that is provided. Okay, so obviously if you have probabilities, you can use the one on the left. If you don't have probabilities, you can use the one on the right. So it really does depend. So as I said, standard deviation is calculating your risk on your asset, okay, and your portfolio of assets. Then we have coefficient of variation. So this is the same formula for both a single asset and a portfolio of assets. Same formula. It is your sigma or standard deviation over your expected return. So this is quite a simple one to remember, and again also indicates risk. Then we have a capital asset pricing model. So capital asset pricing model is another way of calculating a return, an expected return. So we did have initially in this slide deck calculating your expected return using a specific formula, but this can also be used in the calculation. It really is dependent on what is provided. So this is our cap M, so RJ is equal to RF plus beta over RM minus RF. I will unpack each of these items as well as explain, what they represent. And this does correlate with some of the other formulas that we have for Learning Unit 3 and 4 as well. All right, then we're moving on into Learning Unit 4. So Learning Unit 4, we have the nominal interest rate, and here there are two formulas that you need to know. The one is called the common approximation formula, and the other one's called the Fisher formula. So with the common approximation, it's our nominal interest rate represented by I is equal to R plus H. So R is your real interest rate, H is your inflation, and RP is your risk premium. And then with your Fisher formula, basically it's just another way of representing the same items. It's just a different type of formula. So it has the 1 plus I, 1 plus R times 1 plus H. Often these formulas are manipulated so that you can find something else, so not necessarily the nominal interest rate, sometimes the inflation rate or the risk premium. So you just need to understand what the question is asking as well as see what is provided as well. Then the bond valuation. So the bond valuation formula is quite a long formula. So you don't necessarily have to use the formula to value your bonds. You may also use the financial table method and the financial calculator method. Both methods are acceptable. I will unpack those in the mural or the whiteboard that I have for you. So I will unpack those. You may choose any of the methods, whichever one you are comfortable with. And often I get asked whether or not you'll be asked to use a specific formula with bonds, not necessarily. So just understand and use the one that you are most comfortable with. This particular formula, so in your textbook, you'll note that there's two formulas, one without the M and one without the M and one with M, M being the compounding period for small m. So that we need to factor in because a lot of times your bond valuation questions will have compounding, which I will show you today. So generally the M should be there. If there's no compounding, M is 1. So you can just learn one formula instead of learning the two. But I will also just unpack this a bit more on the whiteboard. Okay, so at this point, are there any questions before I go into the whiteboard and just unpack the formulas a bit more with everyone and the different formulas and different methods as well? Okay, so no answer or no comments in the chat, so I'm assuming there's no questions at this point. All right, so I'm gonna share the mural now so we can unpack each of these formulas. Okay, so please just with a thumbs up confirm that you can see my mural, my whiteboard. Thank you, that's great. All right. Okay, so start with the first one. Because you have your expected return on a single asset. Okay, so this symbol is actually also noted as your return on investment, your ROI. So if you see anything where they say to you return on investment, you know that that's also what they're talking about. Okay. It's also called ROI. There are other formulas that represent return on investment, but for your specific purposes and for learning unit 3, it is just it's this formula. Okay, so don't worry about any other return on investment formulas that you may know. Okay, then we have the different elements. Okay, so this is the price of your investment today. Okay, so if you are working with a specific question, it's asking you for basically what it's worth at this point in time. Generally speaking, you're not always at the beginning of a period because that's what your PO represents. So it's about what is the investment right now. So they need to obviously share that information with you. Okay, your POs is the price of the investment at the beginning of the period. So if you have a 10-year period, it would be obviously in year 1. Okay. And then CT being the cumulative cash flows. So what that means is based on the investment, what are you receiving from this investment? Are you receiving dividends? Are you receiving Annuities. So what are you receiving? I just want to double check. Give me a second to check who's not on mute, so I can just update that. Okay, looks like everyone's off mute. Okay, good. All right, so that is your return on investment formula. It's not a difficult formula. The really only trick that could happen is understanding what your cumulative cash flows are. So like I said, it's any dividends received, any annuities received on your investments. So you just need to read the question and understand. Okay, with the second formula for your expected return, we have our RE, which is the expected return. We have our RJ, which is basically the return of the individual or the individual, I would say, outcome. Okay, because they will obviously give you different outcomes. And what I should also include here on this one is just the sum of sign, which I didn't include, because you're going to be adding all your different probabilities. So you're going to have, if you have 5 different probabilities, you're going to be adding them all together. So the sum of RJ times a P, P being your probabilities. So we will do a question like that today so that you can just understand how to do it if you don't have that understanding yet, or just to also summarize or help you refresh your memory on that. It's really not a bad question when they give you probabilities. The only thing is sometimes they include negative values. Okay, so that's your expected return. That's for a single asset. Then we have an expected return for a portfolio of assets. So the only real difference between this formula, so if I had to circle it so that you understand which one I'm referring to. So the only real difference between this one and this formula here, okay, is that we are weighting the returns and then dividing and averaging out over the years. That's really the only difference, because in essence, what we are doing is when we do the weighting, it's actually like a probability that we're calculating. So it's more the weighting and then dividing by, and that's really the only difference between these two formulas. So the principle is in essence the same. Okay, so to go through what everything is. Okay, so this again is your expected return, so it's the same as that. You then have your weighting. So I'll explain the weighting Maybe I'll use a different color because I've already used that one. Let's do this guy. Okay, so when we're talking about weighting, we're basically talking about the value. What are we saying? We're basically saying the value of a specific asset divided by the total value of assets. Okay, so there is a specific formula that we learn later on with a VO, etc. from Learning Unit 5. I'm not going to refer to that now, but in essence, what it is the value of a specific asset. So if you have three assets, each at a thousand rand, you would basically say 1,000 rand divided by the 3,000 to give you your weighting. Really, that's what it is. So it's not a difficult concept. It's just understanding what is required. And today we don't have a question that really asks her to do that, but there are questions in your textbook and also in the past papers that have that. Okay, then your RJ is your expected return. So it would be the same as what we had previously. Okay, those are the same. And then we have your N, which we should know that because that's something that comes up all the time since Learning Unit 2 is your number of periods. Okay. Any questions so far on the expected return formulas? I'm going to double check if there's anything. Yes, so there's a question as to can we do RE is equal to probability percentage times RN? Yes, that's perfect, Mark. You can. So remember, this formula is not in the textbook. It's just something that I created so that we can remember how to calculate it. So if you say RE is equal to percentage, your probability percentage times your return, that's also perfect. I know someone said they can't see, Jack said you can't see the whiteboard, Jack. I'm assuming you can see it now. I'm assuming. I hope so. If not, just let me know. Just type another message. And there's another question about that they get confused with regards to the portfolio of asset formula. Sometimes the formula changed is the difference in the question, with some question requires to calculate portfolio return with only the returns over the years, whereas other question requires to use probability of profit times with the returns. Okay, so to understand when you're dealing with a portfolio, what to do, as in, so what I mean by that is do I use this formula? So maybe if do so I think maybe who asked me that question? It's Mr. D. I think are you assuming more with the standard deviation, or are you referring to when we do expected return? Okay, I'll cover both in case. All right. So let's just go back to this formula. So when you're dealing with your expected returns, okay, so you can with this formula, so I'm just going around in red so you know which one I'm talking about. This one, if they don't give you your weight, as in if they don't give you the values to calculate your weighting, you can actually replace this W with a probability. You can. And then what will happen is you will work it out for each asset in the portfolio, and then at the end, divide by N. Okay, so it really depends. So the question is, I get confused when to use a probability versus when to use something else. Okay, so with a probability percentage, they must give you the probability percentage. Then you know you need to use it. Okay, if they don't give you a probability percentage, then we use a weighting. Same thing when we're dealing with standard deviation, which I'll go through now. If they don't give you the probability percentage, there's a different formula we can use, okay, which I'll go through. If they give you the probability percentages, then use that because that's what they're testing. They're testing if you understand probabilities. Okay, I hope that helps with that question. I'll also just type it in so that you have it. Okay, so I've just posted that in case. Okay, so expected return. Okay, great. So I hope I've answered that, Mr. D, then. Okay, so there's a question as to which the RE, the RE equals probability percentage times Rn. This is referring to your expected return when there's probability, when there are probabilities. Okay, so I've just posted that. Cool. All right. Perfect. Okay, so those are all the questions answered for now. Okay, so let's move down now to these are what I call our risk formulas. So all of these formulas are testing risk. And obviously with any of these formulas, even the risk or return ones, so even these ones up here and these ones over here, we are testing whether or not we have a high risk to give a high reward. Okay, so sometimes the questions will ask you, what is the return you expect? So obviously, if the standard deviation is high, we'd expect a high return. Or if it's low, a low return, etc. So that principle always stays. So just remember that in case it comes up in a question. All right, so let's go through these formulas now. So we have sigma, which stands for your standard deviation. That's what it stands for. And like I said, the standard deviation is a measurement of risk. Let's also make it red, so it's the same. Cool, that's better. I'll fix the other ones as well for us once I've made a screenshot. All right, then this, I know it's not very clear, but this little tick is actually the square root of the sum of. Okay, so it means that when you're dealing with a different probabilities, you will sum each of them. If you're dealing with different assets, you will also sum all of them. Okay, so here we have PJ, which we know from before is your probability. Just want to use the same color so we don't lose that. Okay, purple. Okay, RJ is like we had before. So RJ we had was the expected return of each outcome or of each asset, depending what we're dealing with, if it's a portfolio or not. Okay, so it could be the expected return of each outcome. So that's if we've got a single asset, we've got different probabilities, or it could be the expected return of an asset. So you've got different assets and you need to work out the portfolio. Okay, so you just need to check that. And then we have our expected return, which hasn't changed. So that is our brown guy. And then we square root the bracket part. So what's important is this expected return here. So if I have to highlight again that expected return, I'm just going to use the red. So if I have to highlight this expected return, that expected return often comes from a question that you would have answered previously. So you would have had to calculate this and then this answer. So expected return, you would plug in over here. Okay. And obviously if you do get it wrong, etc., you do get, carry forward marks or method marks for using the number you calculate because you understand that it's the same number. All right, so with this formula here, you can see that Rj is the same, Re is the same, sigma is the same. The only difference now is we have n minus 1. Okay, so we have n minus 1. N being the number of periods. That has not changed since learning unit 2. That's a concept we learned in learning unit 2. And that will not change. And it's normally in years, especially when we're dealing with these kind of questions. But that, in essence, as you can see here, this one, so if I am to highlight it, or just at least circle it, this formula does not have your probability, the purple, in it. So this is when you're not giving probabilities. You've given the return of each asset. You've calculated the expected return, or they've given it to you, and then you've got the number of periods, and then you can calculate. So again, just to reiterate, it's always based on the information that's given in the question. That will guide you as to which formula you can or cannot use. All right, then if we go down to our coefficient of variation, it's very, very simple, our coefficient of variation. It's basically our standard deviation divided by expected return. So it's the same as what we have here. Okay, same. And then we have our expected return, which is the same as our brown guy. Same. Well, I think I used same color. Let me just fix that. So again, this answer is basically a result of the answers you've answered previously. Any questions on the risk formulas before we move on? I'll do the last one for learning unit 3. Okay, no questions. Good. All right, so last one, your CAPM to calculate return. Okay, so you've got your RJ, which is your return. That's the return that you're calculating. I'm just going to keep it in the brown because we've used that for our return, so that's fine. Okay, then we have RF. RF is our risk-free rate. Okay, so you need to be given this number, or what can happen is you can be asked to use this formula to calculate it backwards. Okay, so that's quite common actually, to use this formula and to manipulate to calculate different items. So just watch for that as well. Okay, then we have our beta, as I like to say. I know some people like to say beta. It's fine, whichever way, but it's beta for me. Okay, so your beta, which basically shows you the profile in terms of the market. So what I mean by that, your beta, your market beta is always 1. Okay, but this is obviously the beta for your asset. Okay, so what is important is that you understand that if they give you a question and they say the beta's in opposite direction of the market, they are saying it is negative. Okay, if they're saying beta's in the same direction, it is positive. Okay, so I'm going to just write that in because that's quite important. Okay, so market beta is always 1. Say market beta. And then you do the beta based on companies profiling. That's how it's determined. And, they can give you more information. Then we have RM, which is the expected return of the market. And then your RM minus RF is what we call our risk premium. Okay, so these are all terminology, and I think with the learning unit 3 and 4, it's a lot about terminology because certain words are used and you need to understand what they mean. So if they say risk premium, is, let's say, 20%, then it's the RM minus RF. Okay, so it's very important that you understand all these terminologies because that can be used in a question. And that's how then, this formula can be used in different ways to understand and calculate different things. All right, any questions on this last formula before we move on to learning unit 4? Okay, so see in the chat, Matthew's asking if, for example, it says in the opposite direction, it looks something like this. Yes, that is correct. Would be a negative. And obviously the value would be dependent on the information they gave you. If they said it's the same as the market beta, but in a negative or in the opposite direction, it would be -1. Okay. So you always start off with a market beta of 1, and then companies have different betas based on their risk profiling. Okay. There's a question, what does the RN stand for? The RN or the RM? Just to check. I think it's RM. Are you speaking to the previous formula? Cool. So let's go to the previous formula. Just checking. Where's the RN? Oh, you're talking about the previous formula in the actual chat. RN just means return of an asset. That's what it means. That's all that it means. Yeah. Cool. All right. All right, so let's go to stake here. Okay, so let's go to the next set of formulas. All right, so LU4 or Learning Unit 4 formulas that we have. All right, so with the Learning Unit 4 formulas, the first two that we need to know is the common approximation formula and the Fisher formula. Okay, so with the common approximation formula, basically what we're trying to do is determine rates without inflation or rates with inflation. So this I is your nominal rate. Okay, your nominal rate includes inflation. Okay, so that's what that is. Okay, then we have our R being the real interest rate. So that is the rate without inflation. And then H is our inflation rate. And then RP is our risk premium. Okay, so if we have to look at this formula and I just want to try to see if you can squeeze it in. If we have to look at our common approximation formula and our CAPM, there's similarities. In case you guys were wondering or wanted to understand the link. So you can see here, if I take this all the way up here, this is the same. Your RM minus RF is the same as this risk premium here. Okay, our risk-free rate. So this risk-free rate is the same as this rate here, the real interest rate. Okay, so those are the same numbers. Here we've got inflation. The inflation's not really taken into account. It's sort of taken account with your beta, but not really. And then, yeah, you've got your expected return or your nominal rate here. So just to understand, your risk premium and your risk-free rate and your real interest rate are the same numbers. Okay, so if you get a question where maybe there's a combination of items and they're asking you to use one or the other formula, these are the similarities. Okay, then with our Fisher formula, it's the same thing in terms of our I, our R, and our H. There's no RP with our Fisher formula, so there's no risk premium considered. It's only about looking at the nominal rate, the real rate, and the inflation, that's all. So no risk premium is considered. Just so that you are aware, your common approximation formula can also exclude your risk premium. So if there's no risk premium in your question, it's 0, or you can actually exclude it. It's up to you. All right, now with our last formula, which is your bond valuation. So with your bond valuation formula, okay, this is the value of your bond today. Okay, we then have our PMT, which we know from Learning Unit 2. It's not something new to us in terms of this subject specifically. So PMT is our annuity payments, as we like to say them, or our payments. Okay. We then have our R, which is our required rate of return. With bonds, they tend to use yield to maturity. So if you see yield to maturity, that's another word for the interest rate on a bond. So please don't get confused. If you see required rate of return and yield to maturity, you need to use your yield to maturity. That's what you need to use. This is quite light. I'm just going to make it a bit darker. Otherwise, it's just too light. Okay. Then we have our M, which is our compounding period. So if it's compounded daily, it's 365 or 366, depending if it's a leap year or not. Compounded quarterly, it's 4. Compounded biannually, it's 2, etc., etc., as we learned in Learning Unit 2. So this is nothing new. The M, we've had it before, just for us to remind ourselves and bring it back in from what we had. And this is the small m, not the capital M, the small m. Okay, so please, the big M is actually your par or face value of your bond, but I'll write that in as well now. Okay, so M is like I said, your par value, face value of the bond. There's different words for it. So nominal value, par value, face value. Basically, it's the amount that you're going to get back on the bond at the end of its period. So like I said, you need to understand this terminology. You need to know what these mean. Okay, so if they say to you par value or face value, you understand what it means. But in essence, it's a value of it's how much you're going to get at the end of the maturity period for the bond, excluding the payments. Okay, so excluding that. I'm just going to move this down because I just want to shift it down. All right, so with the bond form, and there's also N here, which I haven't circled, but N is also oh, I'm just checking. Can everyone still see my screen, hey? Because it looks like it wasn't sharing, but I just want to make sure. Ah, see, no. Okay. Something happened. Do apologize for that. Okay, so where did you not see me from? Just so that I can catch up and go back. The final formula. Okay, so I'll go through what I've done and then sorry, but thanks for letting me know, guys. Yeah, I don't know what happened, but yeah, it's back now. So with the last formula, so you've got your the value of your bond today. Okay, so that's in your pink. Your PMT is your annuity payment. Okay, so how much you need to pay over the compounding period. You've got your R, which is your required rate of return, or it can be called your yield to maturity. You've got your M, which is your compounding period. Your small m, compounding period. Your big M is your face value, par value, nominal value. That is, in essence, the amount that you're going to get back for the bond at the end of its life without the payment amount. And then you have your N, which is your number of periods. Okay, what I wanted to show you quickly now is, in essence, this formula is a combination of two formulas from Learning Unit 2. It is your present value of your single amount and your present value of your annuity. So this section of your formula, you can see before the plus, is your present value of your annuity. Okay, it's the exact same form you go back into Learning Unit 2. And obviously it's an ordinary annuity, not an annuity due. Okay. Remember, your ordinary annuity is an annuity that you pay at the end of the month, not at the beginning. Okay. So this is the present value of your annuity. Okay, so that's that formula. And then the second part of the formula, this section, is the present value of a single amount. Okay. Literally, that's what it is. So this formula is actually not new. You know it from Learning Unit 2. Okay, or we should have at least recognized it from Learning Unit 2. I know some of us might have just learned the calculator method, etc., but that's what it is, present value of single amount. So yes, because of that, we don't only have to use the formula method, we also have the table method. So with the table method, you've got your PMT, which is your annuity payment based on your coupon rate. Okay, that's how you calculate it, times your present value factor for your annuity. Okay, so this is the first part of the formula. And you go to your table. So as you did in Learning Unit 2, if you prefer the table method, you basically go to your table, you find the present value factor for your annuity, an ordinary annuity, and then you literally plug it in here. So you'll get your payment amount times the factor gives you the first half of the formula. Okay. With the second one, it's your nominal value, whatever that is, times the present value factor for your single amount. So that would have been your single amount formula or financial table. Okay, so you can choose any method, whichever you prefer. Then we obviously have our financial calculator method, okay, which is you literally just note down the different elements and the calculations. It's very important to show these as well as the calculations because you get marks for showing these. When you're dealing with a compounding period, there is an option to put period per year, so P/YR, but I've opted not to include it here because I know with the shops, using period per year can be tricky. So all you need to do, if there is compounding, your N, okay, you must multiply by the compounding periods. Okay, so if there's compounding, multiply by your compounding periods. If it's your interest, we divide. So it's nothing different from what we learned in Learning Unit 2. This is the same as what we did in Learning Unit 2, following the same principle. Okay. If you're using your period per year in your calculator, you can opt to not, you don't have to divide by 2 and times, but I like to keep it like that so that I know that I don't make an error. All right. Any questions on this last formula before we move on to some questions now so we can actually apply what we've gone through now? Okay, so then there is a question by Mark. Difference between bond valuation calculation and YTM will be the X and divide by M periodic time period. So, so your bond valuation calculation. So when you're calculating the value of your bond, you use the formula. If you're calculating your yield to maturity, you're solving for R. So it can happen that you have to use your formula and manipulate it and solve it for an element. If they've given you a yield to maturity, you use that as your R. Okay, so that's what it is. Whether there's compounding or not, you use it as your R. It doesn't matter. Okay. So I'll just also note that here. Okay. And then it says, do we type the PV as a negative and calculate the value of the bond today? Yes, that's a valid comment, and I'll actually note that on this. So when we are calculating using the calculator, your okay, so it depends what you're calculating. If you calculate PV, your future value will be positive because that is what you're receiving. Your payment will be positive if that's what you're receiving. Okay, because with the bond, it's your present value, the amount that you pay now that you're investing in. So you'll find that if you solve for PV, your answer normally comes out negative. If you need to calculate your interest, for example, because that's what they've asked you to do, you must make sure that your PV is negative. Okay. So I'm just going to make a note here. And why it's negative? Because we are investing in a bond. When we do these calculations, we are doing it from the perspective of an investor. For a bond, I've got to buy the bond. I've got to pay that amount over first. So it's a cash outflow. So my PV is always negative. The payment in the future value is amounts that I'm going to receive. So that's positive. Okay. But I'll just make a note here. So that's a good question there, Matthew, just to remind us of that. Because that if you don't do it, you get a number, but it won't be right. Yes, I've just said needs to be negative when solving other elements. Because when you do this, whatever answer you get as PV is your PV. But when you have to punch in PV to get interest per year, it will be negative. That's a good comment. So I'll also just note that. Okay, so the question is YTM same as interest per year? Yes. YTM is the same as interest per year. Okay, it's just YTM it stands for yield to maturity. That is the jargon used for the interest rate on a bond, literally. And it's because it's representing the interest over the lifespan of the bond. That's why they use yield to maturity. Okay, great. Okay, so the question is, if the payment periods were biannually, is it recommended to put it to 2 periods per year on HP calculator? So, as I said, you may use the period per year on the calculator. However, I don't like using it because I personally tend to forget to clear it afterwards back to 1 period per year. So if I go to a different question and it has a different paying period, I'm going to get it wrong. So I tend to not use the period per year on my calculator. I like to times by n by the m, or the compounding period, and divide my interest by the m. And I'll do that in the solutions, and the solutions I provide for you, the questions, I'll also do that. So I prefer to do that because then I don't forget, because I normally always forget to clear it and put it back to one period per year afterwards when I'm using for other calculations. So it's really up to you, but my preference is to rather multiply the n and divide the interest per year. Then I know that I'm not gonna change my calculator and forget. Okay. Any other questions before we go into past papers now to solve? Okay, so it looks like there's no questions. So the questions I have today, one question relates to learning unit 3, where we have to calculate expected return, standard deviation, coefficient of variation, and manipulate a coefficient of variation formula to solve something else. And then I'll also have a bond question. Okay, so the bond ones are mostly tricky. Yes, so Matthew's question is there's no learning unit 5. No. Test 2 is only on learning unit 4 and learning unit 5. I'm learning unit 3 and 4. 3 and learning unit 4 only. Okay, that's a change from last year. It's only 3 and 4. All right, so I'm going to now bring up the first past paper question so we can go through that together. As I said, it is from Learning Unit 3 first, so that we can make sure we understand how to answer these. All right, so I'm going to share my screen. I'll let you know once it's up. Can everyone see my screen? Just do your thumbs up. Good. Okay. All right, so the first past paper question that we have is a 20 marker. It is on Learning Unit 3, as I said, it's 20 marks. And therefore, for you guys, you times by 1.2 to get to how many minutes it should take you. So it's a 24-minute paper. Okay, your test 2 papers out of 50 marks. So if this was in a paper, it would be just short of, halfway, 40% of your paper, Learning Unit 3. This specific one, and we'll go through it, is actually of a single asset. So it's not of a portfolio. The portfolio one is more difficult. But the same principles that apply here apply to a portfolio. All right, so let's look at the required first. So once we've looked at the marks and how long it's going to take us, let's look at the required. So number 1 says calculate expected average return for Metal Limited. So that actually should be Investments Limited. And round off your answer to 2 decimal places. Calculate the standard deviation. Calculate the coefficient of variation, and then calculate the expected return of Portfolio Victory. So we do have a bit of a portfolio piece in here, but it's more of a manipulating the question kind of. You need to manipulate the formula here. So this does have both single assets and portfolio, but the portfolio piece is quite different to what you would see normally. All right, so it says the portfolio manager of Investments Limited is considering whether to add the below company limited metals to their unit trust portfolio. Investment Limited's portfolio has an investment horizon of a minimum of 15 years as they seek to focus on long-term growth. Okay, and then we've provided with the below information. So remember when I said when I went to the formulas that how do you know which formula to use? here I have my probability percentage and I have my return. So I know that, first of all, because it's a single asset, and second of all, because they've given me probability percentage, I'm going to use my probability formula. That's what I'm going to use. Okay. And just to remind us of which one that is, I'm just going to go back to our whiteboard. Okay. So it's this one here where I've got the bit of a blue block, that guy. Okay, that is what we are going to use. Okay, R is equal to the sum of RJ times PJ. Right. Okay. So part one is calculate the expected average return. Okay, so first step always is we write down the formula. So this just makes us RJ times PJ. I've just done it the other way around. Okay, and when we solve. Okay, so there are different ways of doing this. I know that in your textbook, they tend to do a table format where we just calculate the probabilities. So that you can do it that way, or you can do it the formula method. I'm going to do the table format here. In my solution, I've done the formula method. It doesn't really matter which way you do it, as long as you show your calculation. So either way is acceptable. So I am going to do the table method here. But in my solution that I'll share with you, I've done just the formula method. It's really easy. Okay, so what is critical is you need to decide, and normally it's the probability, which one of these is going to be in a decimal format and which one's going to be as a whole number, just so that you can get the right answer. So I normally like to make my probabilities as decimals. So I'm going to make it 0.10. Okay. Let me actually just make sure I show my. Okay. Yes, I like to do all of mine I like to do my probabilities in decimals. That's just me. Okay, and then to calculate this one, your probability should always add up to 100. So in this case, it's 1. So it's literally 1 minus that, minus that, minus that, minus the last one. Give me 0.25. Okay, so, or 100 minus all these percentages, right? So we must always make sure that our probabilities add up to 1 or 100. And that's how I calculated the 0.25. And then our returns, I tend to leave them as whole numbers. Okay. Because then I can calculate. Okay, then your expected return, I literally just say the probability times the return. So like we have in this formula, it's just the other way around. And I just want to also make sure this is at 2 decimal places as the question requested. And then what you do is you literally sum up your answer. Okay, obviously it's much quicker it's much quicker on Excel, but you would obviously write this out and create your own table. Okay, so part one is solved. My expected return is 6.60, and that is percent. Okay. Right, then number 2 asks us to calculate the standard deviation. Okay, so to remind us of our standard deviation formula. Okay, so it's one of these two. Okay, because we do have probabilities, we can use the probability percentage there. Okay, so we can use the probability percentage. We don't need to use this one at the bottom. Okay, also because it's a single asset, you tend to use the second one for portfolio of an asset. Okay, so I again in my solution would have done formula method. Okay, so I would have included the formula, but we're going to do the table method. All right, so just to remind us of our formula. We're taking this one as the probabilities. Okay, so it is our sigma equals square root, the sum of pj times rj minus re to the square root. So this is a square root here. It's supposed to be a small 2. Okay, so I'm going to do a table again. As I said, in my solution, I've done just a formula method and I just follow the formula, but here I'm doing the table method. Either one is acceptable. You can choose whichever one you prefer. Okay, so you choose what you would like. Okay, so we're going to have our probability in the first column. So I'm just going to copy paste that down. You would obviously write that all out, okay, in your paper. The next thing we're going to have is our RJ minus RE. Okay, this is our PJ or our probability. Okay, RJ minus RE. Our RJ is basically this one. Okay. So you can actually split this up into smaller bits. So I'll do that now just to help us. So I'm going to put my RJ here and my RE here. And then what we can do is we can see, just easier to see how it's calculated. You can obviously just go straight to our RJ, so into this column. So here it's the same. It's my return of each of my asset. My RE, however, is this answer. Okay, so my RE is this answer. Okay. And then this, I'm going to include the square root, is going to be this one minus that. I must just make sure that I show 2 decimal places, because that's what the question asked me. So here I've separated. I mean, you don't have to when you're doing your question. You can literally go straight to this column if you want. It's really up to you. Here I have separated just to make it easier so you understand where the numbers are coming from. These are the same. These are the same. And then this is from that one guy. Our one answer that we got, this one. Okay, so you can understand where everything comes from. And then obviously this is the difference between the two. And then we are going to square root. Or we're going to square it, not square root it, square it. Okay, we then sum up the answer here. And then we need to square root and so our answer is 27.45%. Obviously, I've used Excel formulas, etc., but you would need to use your calculator. All right. Any questions with that one so far? Just want to double check. Okay, so they're asking you, so the question here is, can I write the probability as a whole number? So you need to decide one or the other. Either the probability must be a whole number or your return. One of them must be, not both, because you do both, or you can leave the one as a percentage, right? Just to say 10%, but you can't have both as percentages. So it's got to be one or the other. Okay, so I'll just answer here. Okay, so it's asking, Jordan's asking if the formula is on the formula sheet. I did share an example of the formula sheet in the last master class. I can't remember if it's on there. There are some that are on there, some they are not. So I always just tell my students to learn them all because you never know what's going to be on your formula sheet. But I will share the formula sheet again. Okay. Well, you are right. I am supposed to multiply by the probability. I forgot that. Boop, boop, boop. Thank you. So let me do that. Okay, because remember it's that times squared, and then there's still one more step. Thank you. Where I have to multiply by the probability. Thank you so much. Minus RE to the power of 2. Yep, because that's the whole point. There we go. Much better. Thank you very much for that. Yes, that looks better. Good. Oh, this one doesn't want to work. But alrighty. Any other else? Oh, can both be decimals. So you can, so the only thing with having both be decimals, Mark, is that you're going to have to remember then to convert your answer into a percentage, so times by 100. So both can, but then you have to convert to a percentage at the end. Yeah, so I tend to always choose one, so I don't have to worry about that. It's already done for me. Okay. Of course, I'll show the answer again. See, let me hide that. Okay, so the answer is PJ. There's obviously your probability, your return for your individual probabilities, your return overall that you calculated. We then say RJ minus RE, RJ minus RE to the square root. We're square rooting it, and then mustn't forget to times by the probability. Thank you, because I did forget to do that. We sum that, and then we square root it to get our answer. It was actually not even a, yeah, we leave it like that. Cool. Any other questions before I move on to number 3? Okay, I'm showing you the question and the answer. I hope it's answering your questions. Everyone comfortable? So someone's saying they can only see 1.1. Oh, you mean the rest? Ah, I get what you mean. There we go. Does that help? I'm with you now. 1.2. Calculate the standard deviation. Happy? Perfect. Good. Okay. All right. Let's go to question 1.3. So it's calculate the coefficient of variation. So let's go back to our formula that we did. So remember, this is our formula for coefficient of variation. So it's actually divide by our RE. I'm just going to put it on one line. So it's very easy because you literally take your answer from here and divide by that one. So basically, I'm going to say this. Excuse me. Let's just put it here. Okay, so we solve for that divided by that gives me my answer. Okay, so this number we get from here. And then this number we get from the same place as the blue. That's where we got it from. So it's a carryover. Okay, everyone comfortable with 1.3? That really is, you know, really marks that you should get because it doesn't matter what you answer for 1.1 or 1.2. All right, let's do last one and then I'll go back to questions before I go to my the other question that we're going to do. So calculate the expected return of portfolio victory. So here at the bottom, they've given us additional information. So this is different to what we normally get in a portfolio because in the portfolio, they would have listed each asset. They would have given us the probability, the return, etc. Now they've actually given us the answer and they've asked us to calculate the return. So what have they given us? They've given us the coefficient of variation. They've given us a standard deviation. They've given us the total variance. This total variance is just a red herring, as we call it. It's to throw you off. Okay, so that's not what we need. We need these two numbers. Okay, so what it is we're literally going to use this same formula here to calculate the return. We're literally just going to manipulate it. Okay. So we got question 1.4. And let me just bring up the question so you can see it. We are literally going to use that same formula. We're just going to manipulate it now because it's asking us to calculate RE. So if we're calculating RE, we are basically saying it's the sigma divided by our coefficient of variation. So all I've done is I've just manipulated the formula. Okay. So what does it give us? We know for this one, so it's a portfolio now that we're dealing with. Our sigma or standard deviation, 0.75, and our coefficient of variation is 0.05. Okay, so it means our answer is 15. And this is a percentage. %15. All right, any questions on 1.4? Okay, so this last question is based on this specific part. That's our portfolio. It's just showing how you can be asked to calculate expected return on portfolio in a different way using your coefficient of variation formula and manipulating it. Okay, so I'm just going to check if there are any questions. All right, so it looks like there's no other questions. We're going to go move on to our next question. Okay. So let me bring that up for us. All right, so please just confirm that you can see the Learning Unit 4 question, 25 marker, and a fresh Excel sheet. Just thumbs up if you can see it. Okay, good. Okay, I haven't lost you. Good. Okay, so this is a bond question, bond valuation question, a 25 marker, right? So half of your paper. Yeah, so bonds are very important for your paper. And as I said, there's also a lot of theory that can be asked. So please don't ignore that. It's quite important that you understand those curves, right? All right, so let's look at this question. So it's a 25 marker. It means that if we multiply 1.2, you've got 30 minutes to complete it. All right, let's look at the required. It says calculate the profit or loss that Mr. McEnroe would make upon sale of the bonds if he purchased them today, but then urgently needed to sell them after holding the bonds for 80% of their duration so that he could put down a deposit on a retirement home. Okay, so basically what it's asking you now is they're saying you would have purchased a bond now, you then hold it for a certain period and you sell it. So there's two values that you're going to have to calculate. The value of the bond at a point in time now, and the value of the bond if you only had 20% left of it in terms of the maturity date. Okay. Then it says, assume that the annual required rate of return is expected to have increased by 3% at that stage from when he first purchased the bond due to global risk factors being brought under control. So what this is saying to you is that the required rate of return, or another word for that is yield to maturity, will change when you sell it. So the initial required rate of return stays, but it then changes. Okay, so it's very important that we note that. Then it says Mr. McEnroe received 1.2 million from a victory at the Senior Slam tennis event. He would like to invest the money for his retirement. His financial advisor, Mr. Ace, has advised him that with the current uncertainty in the financial markets due to rising inflation and the cost of energy, which has impacted market returns, he should consider investing in bonds. These provide a more stable cash flow as Mr. McEnroe only has 10 years to retirement. So Mr. Ace has suggested that Mr. McEnroe purchase bonds in Topspin Limited. Okay, now they're giving you the information for Topspin. So Topspin Limited offers 20,000 Rand par value bonds with 10 years to the maturity date. The bond pays a coupon rate of 80% per annum, or the bonds, there's more than one. Interest on the bonds is paid quarterly, so there's compounding. And the current annual required rate of return is 2/3 of the coupon percentage per annum. So remember I said to you that initially there is a required rate of return or yield to maturity, and then subsequent to that, it changes. Okay, so this 2/3 of the coupon percentage per annum is your initial required rate of return or interest rate. Okay, so how do we tackle this? So let's go back to our little sheet. Right. Okay, so this is our bonds. This is where we are. So you've got three options. You can use formula, you can use table, or you can use calculator method. So I'm going to use the calculator method because that is, first of all, the easiest and the quickest. And also it will help to clarify in terms of using period per years or not, because I'm not going to use period per year. I'm going to multiply the ends by the M and divide the interest per year by the M. Okay. If you use your formula, you're literally just going to plug in all the items in. If you use your financial table, same thing, you just got to find your factor. Okay. So let's go back to our question. All right, so the first thing that we have to do is we've got to calculate the value of the bond before we sell it. Okay. Okay, so the value of our bond today, in other words. Okay, so the present value of that bond. All right, so we need to get our interest per year. We need to get our future value, or our PMT, our future value, our N, and then we are solving for PV. Okay. So our interest per year is the required rate of return. The required rate of return, they said, is 2/3 of the coupon rate. So we know that it's 18, the coupon rate, because they said it here. There it is, the 18%. So it's 18 times 2 divided by 3, because 2/3. But then what we also need to do is we've also got to divide it by 4. Why? Because we have compounding. Okay, it's paid quarterly. Remember I said to you, I prefer not to use the period per year on your calculator. I want to divide the interest per year by the compounding period. The compounding period, or the M, is 4 because it says paid quarterly. Okay, so if I calculate that, okay, so it's 3%. That's the answer that I get. Right, then our PMT. So our PMT is always calculating using the coupon rate. So our coupon rate is the 18%. Okay, it is 80% of the par value of your bond. All right, so I'm going to say 20,000 times my 18%. All right, but because we are dealing with compounding, I have to divide my PMT by the number of compounding periods. Why? Because that is how much I'm getting paid each quarter. Okay, if I just use the 20,000, I'm using an annual rate. Okay, so if I use the 20,000 and I don't divide, I'm using an annual rate. I need the quarterly one. Okay, so if I calculate that, I'm going to say 20,000 times the 18%, and I'm going to divide this by 4. So I get 900. Okay, your future value is easy. It's your par value, your face value, nominal value of your bond. They've told you it's 20,000. So we know it is 20,000. Okay, so no issue there. Your N, just specify here. So you don't have to do this in your paper. I'm just doing it so it's a bit more clearer for individuals that are reading this for us. Okay. Okay. Right. Then I have my N. So my N, they told me, is 10. Okay. They said it's 10 years to maturity. Whenever we calculate the bond, we always calculate the N as the years to maturity. So how long are we going to hold it? Because of the compounding period, we're going to times it by 4. So we know that this is 40. Okay, I'm then going to punch in all of these numbers into the calculator. I can keep my PMT and my fair value, my future value as positive. That's fine because that's the amount that I'm going to receive in the future. But then when I calculate it, I'm going to get out my present value. Okay, so if I punch that into my calculator, I should get 2694.43. Okay. Any questions so far? Just going to switch to. Okay, so the comment is, why do I get a negative answer? Because we're calculating PV. So remember I said to you, your PV, your present value, is always the investment you make in the bond. So when you punch it into a calculator, you should get a negative answer, which is fine. It doesn't matter. If you've put in a negative here, that's acceptable. Okay, so if you put a negative answer, it's accepted. If you put a positive one, it's accepted. But you should technically get a negative answer because it's telling you how much did you pay for the bond when you first bought it. That's what your PV is telling you. So if you got a negative answer, it's fine. It's good. Yes, I'll just comment on that. Okay, you only use the 80% duration later. So remember, what are we doing now? We are calculating the bond now. That's what we're doing. Okay, I'm just going to answer here. Okay, so the 80%. Yeah, I'll do the 80% piece. Okay, and there's a few things I've missed in terms of the previous question, but I'll get back to that. Okay. All right. The value of the bond today. Okay, now what we now got to work out is how many bonds did Mr. McEnroe purchase? Okay, and the reason why is because they want us to calculate the profit or loss that Mr. McEnroe would make up upon sale of the bonds. Okay, it's an S. They're not asking for one bond. There are multiple bonds here. Okay, so this question isn't very clear on that, but there's multiple bonds here. Okay, so we have to calculate how many bonds he has. And the reason why we do that is so that when we can calculate the total profit and loss. Okay, so we've got the full value. Okay, how do we calculate the number of bonds? It's your investment value divided by your value of bond today. Okay, so what I mean by that? Okay. So the total investment value is the 1.2 million that Mr. McEnroe received. Okay, so he had received 1.2 million. That's what he wants to invest in his bonds. Oh, that's what he's going to use to purchase his bonds. The value of the bond today is your answer that you received. Okay, and then that will then give us our answer. So if I calculate it, well, I'm going to take out the negative for now. Okay, so I get 44.55, which is basically 45 bonds. Okay. So that's how many bonds he would have purchased with his money. Okay. So now that we know, first of all, how much of the value of the bond when he initially purchased it, or the bonds when he purchased them. Maybe I should just put an S so we know it's for more than one. How many bonds we purchased. We now can calculate what value is going to sell the bond at. This is when the 80% comes in now. Okay. So when he sells his bonds now, 80% of the time has gone. Okay, and the interest rate has changed. So your interest rate is still going to be 18% times 2 over 3, or 2/3. But what has happened is you've got a 3% increase. So you're going to then add the 3, and then this entire amount is going to get divided by 4, because you're still compounding quarterly. That hasn't changed. So I'm going to say again, it's the same interest rate as we had before. The only difference now is we are adding the 3% because now there's been a change in the global risk factors, but we're dividing the full amount by 4. So if I calculate that, I get 3.75. That's now my interest. My payment amount is going to be the same. Nothing changes. It's still the 20,000 at 18% divided by 4. That hasn't changed. My future value is still the 20,000. That hasn't changed. Okay, but now my N has changed, because now we're saying we're going to sell it once 80% of the time has gone past. And with bonds, we always calculate using the years to maturity. So if 80% of the time has gone, we need to calculate the bond for 20% left. Okay, so we're going to say 10 times 20%, or 0.2. That times by the 4, because we have compounding period. Okay, so if I calculate, I'm going to say 10 years times 0.2 times 4 gives me 8. Everyone comfortable so far? Okay, and I'm going to repeat again. The reason why I'm using 20% is because 80% of the time has passed when we sell these bonds. And whenever I calculate the value of my bond, I always calculate based on the years to maturity, always. Okay, right. So then I calculate my PV. Again, if you are calculating PV, you should get a negative answer. Okay, I'm going to note it as a positive, but it's going to come out on your calculator as a negative. Okay, so we should get 2102.42. Okay, I'm going to check if there's any questions at this point. So I'm just going to go to the screen. So the question is, do we have to calculate the number of bonds? Yes. Because we need to show the total profit or loss, which I'll show you now. Oh, perfect. Thank you for answering. Okay, I'll explain the interest per year again. Okay, so the interest per year for this, I'm going to say again, it's 18, because they said your required rate of return is 2/3 of the coupon percentage. It's there in your question. So it's 18% times 2 over 3. And then because I'm selling the bond in this part of the question, it says assume that the annual required rate is expected to increase by 3%. So I'm taking my original required rate of return, which is 2/3 of my coupon percentage. I am increasing it by 3% as per the question, and then I'm dividing it by 4 because we have quarterly compounding. Okay, that's why I've got 18 times 2 over 3 plus 3 divide by 4. I hope that answers or clarifies it now for you. Cool. All right. Right, so now let's calculate the last part of this question, because the question was, is there a profit or loss? So we're going to calculate the profit or loss. Okay, so our profit or loss Okay, it's going to be a value of bond when sold less value of bond when purchased or today. And we've also got to multiply it by, sorry, I forgot to say, we've got to multiply it by the total number of, by the number of bonds that were purchased, because we want the total profit and loss. So I want total profit and loss. That's what I want. I don't want profit and loss on one bond. I want the total. Okay. So what was the value of my bond when I sold it? It was that. Okay. What was the value of my bond when I purchased it? It was the initial value. Okay. And then I'm multiplying it by the 45. Okay, so this 45 comes from here, just that we remember where we're bringing it from. This 26 comes from our answer. So again, if you by chance got this wrong or missed anything, if you're carrying through the right values, you will get it right. If you're carrying through your answers you've given it right. So if we calculate this, we're going to say it is the 21020.42 minus the 26934.43. And we know we're going to times it by 45. Okay. Okay, so the total loss that you make is 266,130. Okay, so that is why you need to calculate the bond or the number of bonds, because you need to show what is your total profit or loss. Yeah, obviously, if the value of the bond when sold, if it was higher than when you purchased it or when the value of the bond today, you would get a profit. But in this case, you've made a loss. So the question in the chat is, so for every question that they sold a bond, we must calculate the value of bond today and also the value of bond when sold. It depends, right? Because maybe they've given you the value of the bond on that date and you must calculate the sold. You need to read the question. But in essence, yes, you need to have a initially purchased and sold amount. You must. Okay. Okay, so you don't always have to calculate. I can give it to you. Okay, so the question is, and if they said bond, so with one S, instead of bonds, we would then exclude the 45. Yes, technically, but also I think the big thing with this question is they said that he received 1.20 and he wants to use all of that to purchase bonds. So that's also the dead giveaway. It's not only the fact that there's a no S, right? I mean, that's one of the things. I mean, it's hinting to you. But the bigger thing is that Mr. McEnroe received 1.2 million and he wants to use all of that to purchase bonds. If he said he only wants to purchase one bond with this money, different story, or half of this money for bonds. I mean, you could also say half of that money if you want. Yeah, but I think the key thing is this. This is what's saying that he wants to use it. He wants to invest all of it. That's when you know there's more than one bond, because if the bond's 26, there's no way he would have used his 1.2 million. Oh, so you want to see the answer again? Okay, let me show you. Okay, any other questions at this stage? Okay, so I'm going to stop sharing. Okay, so someone said they get 3.0075 and not 3.75. You must get 3.75. It means that you're doing something. So what you have to do is you have to, okay, so let me just share my screen again so I can explain. You have to say 18 times 2/3 in brackets, and then add the 3 on top, and then divide by 4. If you don't do it that way, you don't get the answer. But this is the 3.7. I mean, that is, I've even done it in Excel, and Excel won't spit out a wrong answer unless I've put in the wrong amounts. But you've got to say 18 times the 2/3 first, then add the 3, then that answer divide by 4. Very critical, the order. Does that answer? Are there any other questions? Okay, so I just want to double check. I think there were 2 messages that I missed. Okay. Okay, so I just want to check, Neelam, you had this message here. I just want to make sure that I've answered. Okay, so if there's no other questions, no other comments, nothing else, that's it for our masterclass today. It is from 1 to 3 o'clock. So to reiterate, okay, so I'll go back to that. So to reiterate, learning unit, it's test 2 is on, learning unit 3 and 4. Learning unit 3 is on expected return, standard deviation, coefficient of variation, which is risk and return. Learning unit 4 is on bonds. Okay. There are formulas that you have to know. I will share an example formula sheet from a test 2 so you can see what's there. But my suggestion is to make sure you know all your formulas. Make sure you know how to use them. There is theory in 3 and a lot in 4. Make sure you know that as well, especially the curves. Okay. That's a short summary. All right, so to get back to Neelam's question. Okay, so the question is, why did we multiply probability to get standard deviation? So with that question, and I'll just share my screen for that. Okay. The formula is the square root of the sum of Pj times Rj minus Re to the power of 2. So here you've got your probability. So you have to multiply it. You must. Okay, that's why. So you've got your probability. So I've got to say probability times this Rj minus Re to the power of 2. I have to do that. Okay, as per the formula. Yes, I do think there is someone off mute that I'm just gonna take off quickly. Okay, does that answer your question? Cool, thanks, Neelam. Okay, Chris, I will go back to the answer for the last question, and then I've got a minute left, so I need to yeah, close it up. So the answer for the last question, here we go. Okay, again, I will make sure that this material is shared with you. The video will be uploaded on the YouTube channel. All of that will be shared with you. So please make sure that you do have it. So all of this that I've covered will be shared with you. Hey, Chris, are you okay with this? Oh. Okay, perfect. That's it, everybody. Thank you so much. All the best for your test next week. I'm sure you'll all do great. Yeah, but if you have any questions, more than welcome to reach out. Good luck. Thank you.